Hello grade 12s. This is paper 2. It's DBE May-June 2014. Ugh, man. And I'm just going to go through the memo and try and explain stuff. Oh, well, that's in black. Anyway. Okay, for the first one, unfortunately, it is a theory question, so you have to kind of have studied it. You can't really guess it. It's a 4-mile group, which looks like this. I know it's in your notes because I kind of put it there, but if you draw out the structural formula of the functional group, it's that. Please remember, all carbons must have 4 bonds. The functional group of an aldehyde is a 4-mole group. Carboxyl is for an acid, it's this one. So if you have to draw that one out, it would be like that. Carbonyl is for a ketone, and it looks like that. And hydroxyl is for an alcohol, and it looks like that. So the carbon has to have 4 bonds, so you just draw lines to show that the carbon has 4 bonds. Oxygen must have 2 bonds, and hydrogen must have 1 bond. So aldehyde is 4-mile. The only real way you're going to know that is because you learnt it. Carboxyl is an acid, carbonyl is a ketone, and hydroxyl is an alcohol. Then, next one, they're asking how you are going to find an unsaturated compound. So, if we're guessing between 2, it's definitely not this one. And I don't know whether you can tell, but it's because this thing on the left is not unsaturated. So, unsaturated stuff has a double bond. So that would mean it would be CnH2n plus 2. This is saturated. So if you just look at this one quickly, it's 1, 2, 3, 4, 5 carbons. It's C5. And 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. That means it's saturated. So it cannot be that one. They want to identify an unsaturated thing. And you can see the unsaturated ones because they've got a CH over there. So the CH over there and the CH2 implies that there's a double bond at that position. And again, it's a bit of a theory question. What happens is bromine, Br2, is brown. This guy is brown. And in the beginning, when you add the bromine to the unsaturated compound, the bromine undergoes an addition reaction. This is halogenation. And the bromine gets less brown. The solution gets less brown because the Br2 is getting added onto the compound to make a halogenated alkane. So when the Br2 disappears, you know that it was unsaturated. This is not brown, so that doesn't help. And hydrogen is a gas, which is also a colorless gas, so that also doesn't help. So 1.2, unfortunately, is once again a bit of a theory question. You can maybe also guess it, just because there's 2 that have bromine in their answers. So bromine is correct, but so this is correct, but this one is not unsaturated. So you could maybe go that way if you liked as well. Bromine is the answer, which is why there's 2 options to try and confuse you, but only one of them has an unsaturated. This is unsaturated. Anyway, that's another theory question. Then they're asking for the empirical formula of ethyl ethanoate. So now again, this is a little bit complicated, I suppose. Ethyl ethanoate is an ester, so we start with a cocoa. Ethyl ethanoate is an ester, 2 words with yl and OH. So we start with a cocoa. Ethyl and ethanoate, it's 2 carbons each. And then if we add the hydrogens, we just need to make 4 bonds for each carbon. So we add hydrogens to ensure that each carbon has 4 bonds. And if you just use the eyeball method, it's C4H8O2, 1, 2, 3, 4, 5, 6, 7, 8. And that is ethyl ethanoate. So that is trying to make you answer this one. But they want the empirical formula. The empirical formula is the simplest ratio. So divide by 2, divide by 2, divide by 2, It's this one over here. It's A. Okay, next up. This is a very confusing thing to look at. I'm so sorry about that. And there's lots of numbers in the question. But if we can just look at the numbers and see what's happening with the numbers, like with physics, 40 degrees Celsius, 40 degrees Celsius. The temperature is exactly the same. Excess hydrochloric acid, excess hydrochloric acid, that is still the same. The only difference is between the 5 and the 10. So we used to have 5 calcium carbonate. We now have 10 calcium carbonate, but it says it's the same. So it's not that they powdered it or did anything to the calcium carbonate. There's simply more of it. So with that in mind, we need to look at which reaction corresponds. It can't be this one and it can't be this one, because the original one, the OG, is P. This is the original reaction. And we now have more calcium carbonate. The hydrochloric acid was in excess, so the calcium carbonate predicts or determines how much product you're going to make. So P was making, and sorry for the imaginary numbers, but P was making 5 product. Now that we've added more, it must be so it must be this one or this one. And basically the next question is, so number 3 has exactly the same rate as the original, and number 4 is slightly faster. That is also a bit difficult to understand, but basically rate is equal to gradient in this graph. The steeper the line, the faster it's happening. If you don't understand that, I can try and show you now quickly with this green. If I go across like that, and I just say, sorry again, made up numbers, but 8 CO2. It took 10 seconds to make 8 CO2 with this line. It took 5 seconds to make 8 CO2 with this line. This IV, number 4, is faster. It's made the same amount of carbon dioxide, but it's taken less time. Again, the numbers don't matter, but if they help you understand it a bit better, then go for it, give it horns. If you can't see mathematically that number 4 is steeper than number 3, you can just make up numbers. So again, just to do that again, sorry if it's confusing, but yeah, here's 20 carbon dioxide. 20 carbon dioxide, again, I'm not even saying a unit, but this one took 20 seconds to make 20 carbon dioxide. This guy took less than 20 seconds. This one, IV, was faster. And if I increase the amount of reactant, it should increase the rate. It should happen slightly faster because we're doing this in terms of effective collisions. If there is more reactant to react, there's a larger surface area, which means there will be more effective collisions per unit time. And so the graph that we wanted is number 4. So step 1, we need it to be a higher graph. Because there's more reactant, we will make more product. So that immediately tells us it's not number 1 or number 2. So again, we're immediately guessing between 2. And because there's more reactant, the reaction will happen faster. Okay, so number 1.5, this is a KC question. And they are saying, you just need to figure out what's happening. They are adding a few drops of concentrated hydrochloric acid. They are adding this bad boy over here. How are you supposed to know that? An acid donates a proton. An acid donates a proton, and a proton, if it's in a solution, is just H3O+. Because H+ with water is just H3O+. So basically, they are increasing the amount of that blue one. Increasing the blue one, we are increasing a reactant, and that would favor the forward. Increasing a reactant will favor the forward reaction in order to get rid of that excess reactant. So Le Chatelier's principle is basically whatever you do, the reaction will do the opposite to cancel out what was done. You add extra reactant, the reaction will use extra reactant, and the forward reaction will be favored. So that one is not going to happen. So number 1 is not going to happen. So which one should it be? This is now the only option. If the forward reaction is favored, this one will increase and the solution will become more orange. So if you can't work out what it is, work out what it definitely isn't, and sometimes that actually really helps. Okay, number 1.6, another KC question. They say that the equilibrium constant is 1 times 10 to the negative 4. I don't know whether you guys know about scientific notation, but basically this here means that there's 4 zeros. There's 4 zeros, and the comma is always between the first 2 zeros. So that number is 0,0001. It's very small. All you need to get from this information here is that it's very small. If it was 1 times 10 to the 4, it would still be 4 zeros, but the 1 would be over there. It would be 10,000. So this one would be 10,000. This one is 0,0001. And it is very small, which means you've got much less product than reactant. And if you've looked carefully, which you may or may not have, B is a solid, so B should not be in the reaction at all. So once again, not that one, not that one. So we are guessing between C and D, and the KC is very small, which means we don't make very much product, and so that means that C would be the answer, where it's saying that the concentration of A, which is a reactant, is much higher than the concentration of C and D. B does not have a concentration because B is a solid. You can't get a concentration of a solid. You can't have a concentration of table salt. It's just 100% table salt. It's not dissolved in anything. It's not a mixture. So you can't get a concentration of a solid. Solids are not included in KC expressions. Okay, so then 1.7, acids and bases. This is also a bit tricky, because what the hell is this? So now again, oxalic acid, we have no idea what that is, so that means we can't answer the question. If we can just look at this guy, this is CH3, so you should be able to draw this, but also maybe not. This is CH3. It's an acid, and it's got 2 carbons in it. This is an acid with 2 carbons in it. Both of these are the same thing. This is an acid with 2 carbons in it. You should know that that is acetic acid. It's vinegar. So if you don't know what oxalic acid, you do know that this one at the bottom is acetic acid or vinegar or ethanoic acid. Sorry, you probably don't know acetic. It's ethanoic acid. So basically, it's not that you know what oxalic acid is, but you do know that this one at the bottom is ethanoic. So it's not either of those. Oxalic acid, you've never heard of it before. You've also equally never seen this before, so let's pick that one. Or this one. And in grade 9 you did it, grade 10 you might have done it, grade 11 you definitely did it. An acid and a base makes a salt and water, an acid and a base makes a salt and water, an acid and a base makes a salt and water. So if you didn't know about the oxalic thing, you could at least delete that one definitely and this one, and then guess between the two in the middle. I would hope that you would know what vinegar is, or ethanoic acid. It's definitely not the ethanoic acid one because they said oxalic acid. So by process of elimination in 7 different ways, you can hopefully get that 1.7 is B. Okay, so 1.8, it's kind of a combination between KC and acids and bases. The Ka value, this thing here, is basically the equilibrium constant, specifically for an acid. So you get Ka, which is for an acid, and you get Kb, which is for a base, and you get Kc, which is for any reaction. So Ka is basically the equilibrium constant for an acid reaction where the acid makes H+. So like with Kc, the higher the number, the stronger the acid. A high Ka means it's a strong acid. I'm looking for the weakest acid. Again, if you don't know what you're doing, we need to guess either the biggest or the smallest number. So again, we're not guessing between 4, we're guessing between 2. This is the smallest number, and this is the biggest number. Again, if you remember what I showed you with the scientific notation, there's 2 zeros and a 6 5, which is bigger than 2 zeros and a 1 8. And the minus 6 is going to be the smallest because it's going to have 1, 2, 3, 4, 6 zeros and then a 4 5. So this number is the smallest one, and this number is the biggest one. We want the weakest acid. We want the smallest number. The smallest Ka value means it is the weakest acid. So again, if you're guessing, you're basically guessing between the biggest and the smallest numbers. So even if you don't know anything, you must just be smart with your multiple choice, or I would actually prefer you just leave it till the end and just smash through them right at the end, because they're the easiest way to get marks quickly when they say there's only 5 minutes left. Okay, unfortunately for this, 1.9 is a bit of a theory question. This is for electroplating. So this is actually electrolytic. This is normally question 9. So this one should actually come last because it's the last question in the chemistry paper. So I'm not sure why they did that. But for galvanic and electrolytic, there's oil rig. Oxidation is loss, reduction is gain, always. And there's another thing called, I don't know how you feel about this, but there's fat cat. The cathode always gets thicker, and the anode always gets thinner. Fat cat, cathode gets fatter or thicker, and the anode, what am I doing here? Oxidation. Oxidation is loss, reduction is gain. So oxidation is loss of electrons, reduction is gain of electrons. Oxidation means you lose mass, reduction means you gain mass. That's also true. And fat cat is saying that the cathode always gains mass. The cathode is the one where reduction is happening. There's also red cat. The reduction is where cathode is, the cathode. Reduction happens at the cathode. So if you just know that one thing, if you know fat cat, the cathode gets thicker. So if they say the mass of the cathode decreases, it's not that. The mass of the cathode decreases, it's not that. So if you only know fat cat, you would be able to guess between B and D. The solution is copper sulfate. What's happening at the anode is that copper is getting oxidized to Cu2 plus and 2 electrons. And what's happening at the... Sorry, did I say cathode? What's happening at the anode is oxidation. The copper is getting oxidized into copper 2 plus ions. This one is getting eaten up and disappearing. This one is getting thicker. What's happening here is reduction. It's getting the 2 electrons and making copper. But as the oxidation side makes this, the reduction side takes this. So there is no change in the electrolyte. There is no change in the color of the electrolyte because as the anode is making Cu2+, the cathode is taking it away. So Cu2+ is getting made, which would theoretically make it more blue, but then at the same rate, Cu2+ is getting removed, which is then making it less blue again. So the overall color stays exactly the same. The concentration of the electrolyte in an electrolytic cell stays the same. I'm just going to try and rub all this out so I can see number 10. Number 10 is also going to be a bit of a trick. This is a galvanic question. Oh, sure, but it's not even on here. What? There's number 10. Oh, there's number 10. Ugh, silly Terry. Stupid. I knew it was here somewhere. Okay, so this question, well, it's easy if you know, it's impossible if you don't, I suppose. For the galvanic stuff, spontaneous is galvanic. It's question 8. And it's always top right, bottom left. But, again, if you don't remember that, so let me just try Okay, so I'm gonna try them in different colors. So this one I'm gonna do in red, and I'm gonna find Br2, which is here, and I'm gonna find Cl minus, which is there. Then I'm gonna see if I can find the next one, which is Fe3 plus and 2I minus. Fe3 plus. Oh goodness. Fe3 plus. Okay, I really should have done this in advance without you guys watching. Okay, sorry, I paused it a bit and just went for a look. So I minus is over here, and Fe3 plus is over here. However, Fe3 plus is also over there. So to be fair, I'm just going to try and get both of them. So there's two Fe3 pluses, so that's a bit confusing. But anyway, let me keep going because I know it's top right, bottom left. Then this guy I'm going to do in blue. Ni2 plus is going to be here, and H2 is there. Then, last but not least, in the green, I have Cu and Pb2 plus. So Cu is there. Cu is also there. And then Pb2 plus is here. So now, I hope you can see clearly now. For the blue one, it's top left, bottom right. For the green one, it's top left, bottom right. For the black one, it's top left, bottom right, but there's also top right, bottom left. And for the red one, it's top left, bottom right. So the blue, the green, and the red only have top left, bottom right. So top left, bottom right cannot be correct, because otherwise all three of those would be correct. The only option that has the correct one, which is top right, bottom left, you know it needs to be top right, bottom left, because of the 4 options they gave you, only one of them has a top right, bottom left combination, which is the black one, which is B. It must be B. Top right, bottom left is correct. Top right reacts spontaneously with bottom left. That's what you need to remember for galvanic.